This example comes out of section 1.1, linear functions in the tangent problem. So we're still kind of in the pre-calculus stages here at the start of this section. A couple other reminders about slope. Remember in the last example we said that we use little m for slope, and that equals rise over run. We also should remember, just briefly, that a positive slope means that something climbs as it goes to the right, so this is positive. A negative slope would be the opposite, it drops as it goes to the right, so this would be a negative slope. A slope of 0 means it's perfectly flat or horizontal, so 0 slope means basically that you have 0 rise and some run, because 0 divided by some number is still 0. But if you have a vertical line, you have rise but no run, and if you try to divide by 0, you actually get undefined. Most calculators will say error, and so this has an undefined slope. So virtually every line that you run into is going to have positive, negative, or 0 slope, unless you get the very rare example of something that is a perfectly vertical, straight up and down line. Now, the next example, we're asked to do something specific here. We're asked to find the equation of a line that passes through the points negative 3, 7, and 5, 2. You can, if you choose to, do a little sketch of this. I like to see a picture of something when I'm going to do it. So negative 3, positive 7, 1, 2, 3, 4, 5, 6, 7, something like that. And 5, 2, 1, 2, 3, 4, 5, positive 2, something like that. So there is only one possibility in terms of what kind of line is going to go through those 2 points. I like to use the form y equals mx plus b to start. Some people will use the slope point form, if you recall from way back in Math 10, which said y minus y1 equals m times x minus x1. But either way, no matter which way I go here, I need to find the slope. So remembering that slope is rise over run, my change in y coordinates, y2 minus y1 divided by my change in x coordinates, x2 minus x1. Some books will call that delta y over delta x, just a way of saying change in y over change in x. So for this one in particular, we could say 2 minus 7 divided by 5 minus negative 3. So 2 minus 7 is negative 5. 5 plus 3 is 8. So the slope of this line segment, or this line here, is negative 5 over 8. So I know that if I'm using slope-intercept, y-intercept formula, but y equals negative 5 over 8x plus b. Now my job is basically to find b if I'm using this form. So I do have some points, x and y, that I can put in here. So if I substitute either one of those, start off maybe with the very first one, and say, well, y equals 7 when x is equal to negative 3. So that means that 7 equals mx plus b, and I have m, I have x, I'm just solving for b. So that means that 7 is equal to 15 over 8 plus b. Not particularly convenient numbers in that we do have fractions here, but if I say 7 minus 15 over 8 equals b, I can say 56 over 8 minus 15 over 8 equals 41 over 8. Doesn't reduce, so the equation of my line in slope-intercept form is y equals negative 5 over 8x plus 41 over 8. Again, if you look up the answer to this one in the back of the book, it won't say that. They'll take that a couple quick steps further, get rid of denominators by multiplying through by 8, so I'll have 8y equals negative 5x plus 41, and then putting it all to one side, I can say 5x plus 8y minus 41 equals 0. On my quizzes or tests, unless I specify a certain format, I would definitely accept this first answer or the second answer. I just show you the second one so you can check your answers in the back of the book.